This video is going to be about pedigrees. The first question we want to ask is, what is a pedigree? Well, a pedigree is a graphic that we can use to track traits across generations. So sometimes we'll use names, but generally we'll just use symbols to describe kind of like a family tree and how a trait moves through that family. So why do we use a pedigree? Well, typically in genetics, whenever we're trying to figure out some things about traits, we'll use things like beans, like Mendel did, peas, or fruit flies. And the reason we use those things is because we can get a lot of generations to turn over very quickly. But with a human trait, you've got to wait sometimes 40 years before the trait manifests itself. So it can be difficult to track that trait unless you start talking to relatives and they start remembering ancestors. And then you can begin to put together this pedigree and get some more information about that family and the traits in that family. And that can help them sometimes make decisions about having children and what to expect if they do. So genetic counselors will often put together pedigrees to try to track traits. But again, sometimes just to understand traits. Geneticists will put together a pedigree and try to get a better understanding of how certain traits work. So what are some pedigree symbols? Typically a square is for male. And I usually remember that by something like males have like a square jaw, let's say. Females are circles, and I remember that just because of the curves. If there's a line going this way, it typically means that the male and female are married. A line going down, a vertical line, means that they had children. Then the horizontal line then will mean the siblings of those children, that little family. So the Roman numeral 1 stands for the generation. So the parent generation is usually the first generation. Because that's as far back as we can go for the information that we know. And then Roman numeral 2 will be the the second generation. The little connector between the two children that looks sort of like a triangle, that symbolizes twins. In this case, because one of the twins is male, the other one's female, they're not identical twins. But if they were identical twins, there'd be an additional horizontal line connecting between the two siblings. If the person has a trait, typically the shape is filled in. So if a male has a trait, the whole square is filled in. If a female has a trait, the whole circle is filled in. If they're a carrier for the trait, a lot of times it's just half filled. All right, so the circle or the square is half filled. And if there's a diagonal line through the shape, that typically means the person is deceased. All right, so whenever we're looking at a pedigree, we're looking for two different types of traits: autosomal traits and sex-linked traits. Autosomal just means the traits are carried on chromosomes 1 through 22. They have to do something with the body. Sex-linked traits are carried on the XY chromosomes, the sex chromosomes. All right, so how can we tell what's what by looking at a pedigree? All right, so if the pedigree is autosomal dominant, here are two clues to look for. Clues 1 and 2. So if it's autosomal dominant, so that means it's on chromosomes 1 through 22, children with the trait will have a parent with the trait. Or if the parent does not have the trait, the children will not have the trait. All right, so if we look at the autosomal dominant example, we look at the children in the second generation here. Children with that trait are going to have parents with that trait. And then if the parents do not have the trait, well, then the children will not have the trait, because that means if the parents are both recessive, they can only pass on recessive genes. All right, so what if the trait is recessive? What then? Well, that's rules 3 and 4. If the trait's recessive, then heterozygous parents can pass the trait to the children. So the trait wouldn't show up, big A, little a, big A, little a. So neither parent has it because the dominant A's are showing up. but there is a 50% chance that they could pass as little a's to their offspring. So in that case, a lot of times the trait will skip a generation because of that. Now, if there's two parents with the recessive trait, then they can only have children with the recessive trait. Little a crossed with little a can only have children that are little a's. All right, so that's our clue number 4. So a lot of times what you want to look for first is how do you decide if it's autosomal or sex-linked? Well, if it's sex-linked, it's generally going to be more common in males or more common in females. But if it's about 50-50, an even spread between males and females, it's probably autosomal. So that's the first thing I look for. Then I want to decide, is it autosomal dominant or recessive? If it's recessive, it probably is skipping a generation, or there's probably heterozygous parents, so parents that do not have it, but children that do. If it's dominant, you'll typically see it in every generation. And you'll typically see that if parents do not have it, then the children will not have it. All right, so take a look at this pedigree. Which is it? Is it autosomal dominant or is it autosomal recessive? Well, hopefully you picked autosomal dominant. And the reason you should pick that is because the parents are passing it to their children. It's every generation. It's pretty equal between males and females. You'll see that there's 3 males that have it and there's 3 females that have it. So what do we look for if we have an X-linked dominant trait? One of the things we want to look for is that it's more common in females. So in this case, we have a father that has the dominant trait, so X big B Y. Well, all the daughters are going to get it because they get the X from their father. So fathers are passing it to their daughters, and they'll pass it to all their daughters. In the case of an X-linked recessive trait, it's going to be more common in males, and it typically skips a generation because that's what recessive traits do, and mothers will pass it to their sons. So for X-linked dominant traits, fathers to daughters, X-linked recessive traits, mothers to sons. Well, that's because a son gets the X from the mother and gets a Y from the father. So if we look at the X-linked recessive pedigree, you'll see that the mother has it. She passes it to all of her sons, but the daughters are carriers. All right, so they got an X from the dad, which was dominant, so that's the trait that's showing up. But you'll notice that it's more common in males, which is a good indication for an X-linked recessive trait. So let's do a little practice. All right, so which is going to be more common in females? So typically, that's going to be a X-linked dominant trait. If it's more common in males, it's probably a recessive one. If it skips a generation, it's probably a recessive trait. If mothers pass it to their sons, because sons only have the one X and they get that from their mother, then it's probably a recessive trait. If fathers pass the trait to their daughters, to all their daughters, it's probably a dominant trait because the mother is giving a recessive X, but the father is giving the dominant X, and that trait's going to show up. Let's take a look at some pedigrees and let's see if you can figure out what they are. So in this case, I notice right away it skips a generation. That's going to make it a recessive trait, typically. Next, I need to decide, is it autosomal or is it sex-linked? So I'm going to look at the number of squares that are filled in, 3 males. Then I'm going to look at the number of circles that are filled in, 3 females. And because it's about even, that means it's probably autosomal. So this one, I'm going to say autosomal recessive. You'll notice that this pedigree has the Roman numerals going down 4 generations, but then it also has numbers going across. That way I could say something like generation 3, individual 2, and you can identify that person as a male that has the trait. So take a look at this pedigree. I notice in this pedigree that the trait shows up in every generation, which means it's probably dominant. The next thing I need to decide, is it autosomal or is it sex-linked? So again, I see that there's 3 males that have it, 3 females that have it, which probably means it's autosomal. So in this case, autosomal dominant. What about this pedigree? In this one, I notice that sometimes the parents do not have the trait, but the children do. I also notice that the grandparents did not have it, but their children had it, and then their grandchildren have it. So that's going to indicate some things. I also notice that it's all males that have it. So in this case, it's probably going to be a sex-linked trait, and it's probably going to be recessive. So it's X-linked traits and recessive. So I hope that helps you understand pedigrees a little bit more and the information we can get from them.